Hey guys, thanks for taking the time in the next 20 minutes to hear me and Deloitte speak about a solution we built out for our customers that we call automated workflow monitoring. My name is Ash. I work for Deloitte as a technical lead of the data engineering work that we do, specifically focused on Databricks. And today I want to show you not just the value add that sort of the ability to monitor your Databricks data and jobs in real time in a single place can provide, but also the value add of taking that data that exists in Databricks, that exists temporarily, and writing it into Databricks in a persistent way that we're calling the centralized analytics data store for monitoring, and the value that can provide. So to start off, let's talk about the current state of how Databricks does all of its data engineering jobs. Can I get a raise of hands if you guys have either heard of or at least interacted with any sort of Databricks workflows in the past? Jobs, clusters. Okay, awesome, pretty much 100%. So you're probably aware already how over time data pipelines get more complex, right? Let's just take the Databricks jobs, for example. They used to be just a start and stop. It's been developed now to have subtasks that are under it. Each of those can have dependencies. And over time, all that sort of complicates the ability for us to monitor what's going on in the Databricks environment, right? That's one side. But additionally, as your enterprise gets more advanced over time, you can start off with 10 jobs and move on to like thousands, right? So the ability to actually see what's going on and find those critical insights becomes essential. Looking there at the bottom left, I'm sure you guys are familiar with this if you've used Databricks in the past. There used to be just a couple options, all-purpose clusters and jobs. And we see this grow over time, right? Just at this last keynote, we talked about vector search, and there'll be things added here in the future. So this poses a few challenges for our support teams and our monitoring teams and operational teams to figure out how to actually track everything that goes on in Databricks. One of the key things is it takes more time to investigate what's happening in the environment. Take, for example, you sign on in the morning and we have 200 jobs that failed. How do we know which of those 200 jobs are essential? Databricks has the same sort of email alerting mechanism. Does it actually prioritize which of those jobs are more essential than the others? That could lead to more operational time spent investigating issues, which then is more overhead costs, right? Secondly, there are a bunch of great Databricks tool sets to actually gather this monitoring information, but it's short-lived. You have to code it. You have to use an API or the SDK. If you wanted to go back in time and say, hey, how is this environment looking 6 months from now, you sort of lose that insight into that data, right? Lastly, we don't monitor the system 24/7. So things could be happening to your jobs or your clusters overnight. They could be shooting up in capacity, shooting down or failing 20 times. It's hard to actually check for anomalies in that data unless you actually have the data available to you so you can give it off to your data science teams, do some sort of like analytical processing in it, right? And then finally, Databricks is great itself as a tool, but oftentimes at our customers, we need to integrate some of the Databricks data and alerting mechanisms with their tool sets, whether they're proprietary or whether it's something like ServiceNow, which is like a common tool, right? Like if your customer is asking to integrate your Databricks data with them, it's a bit harder than to just say, give them access to an API and have them solve it, right? So all these sort of challenges sort of necessitate the need to have that persistent monitoring data stored in Databricks so we can take advantage of it just like everything was mentioned in the keynote, unit catalog, data governance, etc. So we'll go through a very quick overview of the challenges for each of these Databricks components currently. I'm sure you guys are all familiar with jobs. You can see on the left side, Databricks is a great overview for all the jobs that are running in the environment. Clearly see what's succeeded, what's failed. But this data is only temporary. You can't go back more than 2 weeks. So if you want to search back how things was happening 6 months ago, it's sort of lost, right? You could click into the specific job and get a much more detailed output. But again, that becomes a very manual process. And if you can think about the scaling this up to 200 jobs, it becomes much more difficult. Taking a look at Delta Live tables, it's sort of similar story, a very detailed breakout of the meta information on how these sort of like Delta Live tables propagate. And the most recent runs, you can actually just look at the top left and get an output of that. But if you want to go back and see how your pipelines are running, that's a bit harder again. And then finally, all-purpose clusters, right? We're all familiar with this stuff. Databricks has a nice one-page overview of your clusters running. If you want to see what's running, what's failed, that's great. If you want to see why they failed and how many times they failed, all that sort of deeper analysis, that again leads to more manual investigation, right? So to this end, we built at Deloitte what we're calling the automated workflow solution. What it is essentially a single dashboard in Databricks that collects all this information for you so you can just view it in one place. And it's all backed by a single Databricks job that's highly configurable. So if you at your customer don't need to monitor for Delta Live tables yet, if you, a customer, want to have this job run 24/7, or you don't need it as essential and want to run it once a day, all those features are sort of customizable. And you just need to sort of run the code, run the script, and it'll generate this data for you in order for you to make that dashboard. So I'll quickly just jump into a demo of seeing this in action. But this is the Databricks sort of Lakeview dashboards. And you can see at the very top, it kind of gives you an overview of KPIs of what's happening in your environment at the job level, how many jobs are running, how many succeeded, how many failed. And then you can scroll down based on time and actually get the more detailed information off your jobs, right? But something that's also critical is if you have a job that's failed, it'll give you the output and the error of the actual job. So over here, I think we can all see successful job runs. At the bottom, there's a Delta Live table that failed. You can quickly see and get that insight straight away. But more importantly, that also extends to the task level. If you guys have built Databricks jobs recently, I'm sure you've come to the issue where the job has succeeded, but the task fails, and it looks like the job succeeded, and you don't realize that, hey, the job's been stuck. So you need that task insight as well. And the same sort of breakout is there at the task level. You can easily search for the jobs you want and get to the data if you need. Next, it's the all-purpose data, which is slightly a different use case of the data you want. What we've sort of seen in some of our customers is that people use these all-purpose data for development or to connect to their BI tools. And sometimes it necessitates a need to be running 24/7. Sometimes it needs to just run 8 hours a day. But again, when people run this overnight, you don't really know what's happening. Is the cluster spinning up, spinning down? Is it failing for metastore failures? Which essentially means the cluster is being utilized and costing money, but it's not doing anything. So you want to have insight into those actual cluster events, not just is it on or off, right? So that's what this essentially gives. It gives you an overview of what clusters are currently in your environment that are on, which are off. And you can actually break it down by those events, right? So if I want to see, hey, I've been seeing a lot of nodes being lost, that seems like an AWS issue, a cloud issue more than a Databricks issue. Let me just click that and I can see like these are the clusters in my environment that's facing most of those issues, right? And I can do some more investigative analysis of why that is happening. I'll give a quick example at the very end of the talk on like how this actually helped us save money at our client side by specifically finding these sort of like anomalies in the data. And then lastly, it sort of does the same thing with Delta Live tables, right? Track your pipelines over time to see what's failing, what's not, right? So a bit more detail into the actual underlying code that like runs behind this. Like I mentioned, there's a single Databricks job that's created that runs basically off a YAML configuration file in which you can sort of set these values. So everything is backed by unicatalog tables, so you can just enter the tables you want for the jobs, for the tasks, for the clusters, etc. And then you can enable the features that you want it to track. So if you, again, don't need Delta Live tables, just set that DLT tracking configuration to be none. And we want to actually gather that data, right? And then again, being cognizant to the different needs of your customers. Some of them, for big enterprise solutions, might need critical insights straight away. So you just need to change the type of the job to streaming and it'll run 24/7, get you that information whenever you want. This data is backed up with Databricks change data feed. So it means whenever a new record comes in, it's automatically picked up and can sort of propagate throughout the system. If sort of tracking and monitoring of jobs isn't that essential, you can just run this daily, for example. This is a really sort of simplified overview of how the process works. Essentially, the linchpin of getting this data is the Databricks SDK. A bit ironic, I think it was 1 year ago today is when the SDK was first announced at Databricks, and it's sort of their unifying solution to sort of track these metadata operations and sort of deal with Databricks on a sort of like administration level, right? But the SDK makes it very easy to sort of expose the APIs through the code. And so all one needs, once they import the code, is to provide your personal access token as an administrator to the Databricks workspace, and then run the job. And it will use the SDK and kick off APIs to collect the information necessary for the jobs, workflows, etc. Once that happens, it'll generate a Spark data frame and insert those updated records into Unity Catalog backtables and just restart their process again, right? I want to quickly bring up, you guys at the keynote today, did you hear the announcement about the AI BI and how the dashboards can essentially have a chatbot to let you answer questions? There's sort of only one requirement needed for that, and that means your data has to be on Unity Catalog. So Databricks can read the metastore and then like find stuff, right? So that's another advantage of this. So we can programmatically get this data, but by putting it in Unity Catalog, putting it on a dashboard, not today, but in the future, you can ask this dashboard, hey, just tell me the top 5 jobs or clusters that failed in the last 24 hours, where's the most essential, and it'll give you that information, right? So a lot of good like future components of this. And speaking of how to extend this, right? One of the biggest value adds, again, is once you have the data available to you in Databricks, in the Delta Lake, you can then extend it how you want, right? You're not sort of constrained to using an API. So one thing we've done at our customer sites is create customized emails, right? Databricks has a great email like alerting system where you just put the email, if the job fails, it sends out, right? But everything is sort of treated at the same level. You wake up, say tomorrow morning, and you have one of your devs create a job, send you on the email, it failed 200 times, now you got 200 emails. It's sort of like hiding the essential other jobs that you need to look at first, right? But what we've done at a customer site is we actually created a tiered setup of our jobs, which we classify some as critical, some as high. And that actually links into when we actually send out the email, so we can flag it out and say, hey, this is a critical alert. This is a much lower priority, right? So that's part of the process of getting our support teams to figure out what to look at faster. Secondly, the BI tool. So the example you saw is Databricks using the data being shown in the Databricks dashboard. But again, once it's in Unity Catalog, you can link this up to any sort of BI tool. In this example, we're using Tableau, right? Otherwise, without it, you would just give your Tableau developers an API and it'd be much harder to gather that data. They'd have to come up with their own solution to essentially have live reporting. And then finally, the out-of-the-box connectors that Databricks has with Salesforce, or the actual APIs that Databricks makes available with ServiceNow. So a lot of your enterprises might have an actual ticketing system that you want to actually process data engineering jobs or any sort of like outage issues for, right? With this, again, because the job is persistent and sort of you control the code and you control the outflow of data, you can automatically link into these ServiceNow APIs, maybe only the critical jobs and not the unnecessary jobs. So your larger enterprise essentially gets hooked into the Databricks ecosystem that you guys are building out, right? So how is this automated workflow solution helped us at Deloitte with our clients? The first one is improving efficiency. So by being able to collect all this data and actually make these programmatic decisions on what we consider essential, what not, we've been able to create that sort of tiered structure for our alerts. So our support teams and our operational teams can sort of get to the data that they need faster, which essentially saves them time, right? And as they say, time is money, right? So by them having, being able to quicker get to the information they need, saves on operational and maintenance cost. But again, a specific example of how we use that dashboard to help save in another way, we discovered that there was an external business intelligence connection that we had. It was connected to one of our Databricks clusters, only meant to connect to it 8 hours of the day, not 24/7. So we expected it to be turned off and save money, right? What we didn't know was that external application, in their settings, they had a connection pool set to never expire the connection. So even though users were not actually using it, the connection was remaining open, and the Databricks cluster was on and incurring costs 24/7. And so that was something we could never figure out unless there's a manual process. Someone signing in at 2 a.m. in the morning and saying, hey, this cluster is up, right? But by actually looking at that cluster event log, tracking how often the restart event happened or the auto-sizing events happened, we noticed there was an anomaly with this cluster and able to investigate it, found out the issue, made changes, and actually it's saving actual resources utilization for the client. And then lastly, extensibility, like I mentioned with ServiceNow and Salesforce. At one of our Deloitte clients, the client built a proprietary solution to monitor alerts that go in the environment. It's based on a webhook, but it required a very specific schema to be sent and very specific connection details. Databricks out of the box, even though it has great features for webhooks or sending those alerts to, for example, the Teams channel, it couldn't directly connect to this custom application. But again, having unique catalog back data in Delta Lake, you controlling the outflow of that data, we were able to say, hey, for our critical jobs, let's send it to this client webhook. And essentially, we integrated Databricks with our overall client enterprise's 24/7 monitoring service, which saves us, essentially the Databricks developers, time for their support by sort of shooting out to the broader client team in general, right? So again, yeah, we have a few minutes left, but just to summarize, the ability to monitor all your Databricks Metastore data engineering job information in the center place has two main benefits. One, easier for you and your support teams to get you the critical insights that you need faster, but just the general advantage of actually persisting that data, not in APIs, but into the Databricks Delta Lake and Unity catalog, and how that makes that data extensible. And now it becomes an analytic solution, not just a support solution. Should have done a QR code for this, but there's a URL over here if anybody wants to take a snapshot and just read the overall white paper that we built out of this at Deloitte. But looks like we have about 2 or 3 minutes, so if anybody has questions, happy to answer them.
Thank you.